Welcome everybody to Novus Nexus product demo. We'll be showing an automated end-to-end simulation process. First, let's start with this general concept of the workflow for this automatic end-to-end process. So first thing I'll have you note is that everything in this yellow blue box here is the automated process. These component parts are set up beforehand to allow design engineers or analysts to be able to run multiple simulations across different CAD platforms and commercial and open source fluid and structural solvers with a lot of flexibility while maintaining robust, reliable output. So it will start with a simulation-ready CAD model, which is a basic CAD model that's informed by some of this stuff under the hood with some simple text strings coming from the abstract model, string parameters that are attached to the CAD model. Now, a user will upload that CAD model through, in our case, ESA, which is a browser-based web app, and it'll go through that and automatically integrate with CA Nexus, which will take that model together with the abstract model, which is where all the physics is captured in a geometry independent way that can be reused multiple times. And together with the CAD model, the abstract model, CA Nexus will pump out the mesh and the solver input deck already attached to a simulation geometry for any number of solvers. Then automatically that will be fed through our report framework to a post processor of choice, which will then, once that's complete, automatically generate a user-defined simulation report and email it back to the design engineer or analyst. So this is the automated process. So first we'll jump in and just look a little bit under the hood to see what an abstract model looks like, because that is going to inform how you make your CAD model. So here is the CA Nexus abstract model UI. No physical geometry, but instead you see classes and class relations. So you'll see also 4 tabs for meshing, solution strategy, problem definition, output. On the meshing tab, we can define some of those class attributes for meshing. For example, size A is defined relative to size B and C. On solution strategy, we are defining things specific to what solver we're using. In this case, Fluent, we've defined the turbulence model there. For the problem definition, this is really where all of the analysts' simulation expertise is captured. It comes in and is stored related to each class, related to the cell zones, the boundary types, the different parts that are relevant to the physics, whether it's an inlet, an outlet, a wall, a fluid, a void, or a solid. All of these are defined in the problem definition, as well as some of the attributes for your simulation report, which will come later. And in the output setting, you get to define different post-processor attributes as well. So this is where all of the titles that we create in the abstract model are now going to be taken and labeled on the simulation-ready CAD model so that CA Nexus can marry the two together. So here's a CAD model created in Creo. You can see different parts, the inlet, the blower subassembly here, a diffuser, an evaporator down through the casing, and the heater element. And you'll see all of the outlets here, both the defrost outlet, the panel outlets, as well as down here, the floor outlet. And all of these yellow doors through here, these are the doors that will adjust the different angle for the different mode settings. So you can see we've parametrically designed this CAD model so that each of these doors, whether it's the heater door, the floor, defrost, their angle can be adjusted just with a straight numerical value. So the interesting thing about this CAD model design is that all of the fluid parts for simulations, the volumes, those are extracted by the designer and are actual volumes so that the simulation will work. Now, what's interesting over here, if we look at the model tree, is we have these what's called S-comp or simulation components. Now, and then S-class, simulation classes. So the components represent the names of each part, as you can see, the evaporator, the casing, the heater door, etc. Whereas S-class, these refer to what physics it is. So for example, if it's an air, it's going to act as a fluid, what mesh size it needs. And all of these are the titles that we defined in our abstract model under the classes, class relation, and put attributes on them in the problem definition tab. So let's zoom out of that CAD model now that's been labeled and tagged, and we're going to see how through a specific web app that we've created, it can automatically be uploaded to CA Nexus. So here you have Novus Nexus's ESA basic web app, and you can see the user designer in this case can simply choose the CAD modeler, the version, and upload the geometry. In this case, we're uploading the one that we just were looking at. And what's interesting is that we've designed into this UI the ability to select different angles for all of those doors, representing the different modes that we want to examine. In our case, we want to be examining temperature distribution and mass distribution at different outlets for the different modes, as well as pressure drop across different components. And each of these modes is represented preset by these different angles. We've also created the option to manually change the angle to do certain in-between modes. So over here, you can see all we have to do is set the specific solver inputs that we want, the fan speed, and the different models that we want, for example, evaporation or heater, that we want our solver to use. And then we submit the project and it's submitted successfully. So now we'll go and see our dashboard and see how this system is running automatically. For a designer or someone initiating it with all the automated processes prepared in the background, they'll see this dashboard and you'll see that it's preparing the geometry. But we want to show you a little bit about what that means behind the surface, or behind the scenes rather, under the hood, if you will. So here you can see in CA Nexus, what's happening is a simulation model is being generated from that CAD model, a mesh model is being generated, and Fluent is being used to create the volume mesh, and all of those attributes are being prepared and matched up with the relevant parts based on those titles. This allows CA Nexus to pump out a reliable solver input deck, and then once the solver has completed, it'll go through our report framework all under the hood still until a simulation report is emailed to the user, whoever initiated the simulation. So here you can see an example email. We can download the report and look at what's been given for this basic demo. So here is our report, and you can see there it gives you a number of different output depending on what you want. What was the simulation inputs, what the temperature and airflow distribution are, the pressure distribution as we talked about across. Here's the drop across the evaporator and the heater. And then here's, just for validation, the model representation as well as the blower, for example, sample mesh image with the total cell count, as well as various contours for temperature, pressure, velocity, as well as in the sub-assemblies. All of these report parameters are customizable and determined in both the abstract model and the automated process UI. I hope this goes to show just how an automated simulation process can facilitate correct design decisions. Model can capture and reuse the expertise of your analysts. A number of advantages are available here. Thank you so much for watching. If you have any questions or want to investigate how this could be used for yourself, please contact us through novusnexus.com.